In this example, let's say that we have 5 books instead of 7. So let's say we have 5 books. We want to order 3 at a time. So how many different orderings of 3 books are there from 5? Okay, very good. So same process as before. Every ordering of 3 books contain 3 books, so we can use our 3 placeholders and then put the number of options in each. So the first position on the bookshelf has how many options for books? Has the full 5. And then the second position has now 4, and then the last position now has 3. So we're starting with the number 5, and we're multiplying down one at a time until we have a total number of 3. So this is 5 permutes 3. But you notice that this second argument 3 has to do with the total number of objects here. It's not the last number that we end up with. That's just purely a coincidence in this case. So in the previous example, the sum permute 3, this last number ended up being 5, but 3 represented the total number of objects. Okay, so the second number here represents the total number of objects, not the ending number. Any questions? Okay, so 5 permute 3 ends up being the same as 5 times 4 times 3, which is 60. So that means that if we have 5 books and we order them 3 at a time, we're going to get 60. So what we'll do now is we'll actually list out all 60, but it's not going to be as painful as it sounds. We'll list out enough so that you can see a pattern and you'll be convinced that there are actually 60 possibilities. And this will actually pave the way for the next concept as well. So let's start listing out the 60 possibilities. So if we number the books 1, 2, 3, 4, and 5, one possibility is if we put on the bookshelf books 1, 2, and 3. And let me start listing out these 60 so that within the same column, I'm going to list out the same 3 books but in a different order. So like 1, 3, 2, 2, 1, 3, and so on. So how many should there be in this first column?
6.
Yeah, very good. So the same 3 books in all its different orderings should be 6. So we saw something similar to this before, and I'm actually listing out all 6 now. So there's 6 here, and this represents the same 3 books, books 1, 2, and 3, in all its different orderings. So in the next column, I'm going to do a different set of 3 books. So maybe a different set of 3 books might be 1, 2, 4, for example. And then within that column, I'm going to list out all the possibilities of those same 3 books in all its different orderings. So this will be 1, 4, 2, and so on. Okay, and then if we try to list out all 60 books, where each column has all the different ordering, so each column is going to always have 6 rows. Therefore, how many columns should we have?
10.
Very good. So there's a total of 60, and there's 6 rows, so there needs to be 10 columns. So because we know from the outset that there's only 10 columns, let's go ahead and list out what all 10 columns should be. So we already have 2 columns, so let's list out the remaining 8. So each column again represents a distinct set of 3 books. So what might the next column be?
1, 2, 5.
Yeah, very good. So 1, 2, 5. And then within this column, we're going to list out all the different 6 orderings of only these 3 books, 1, 2, 5. But you get the idea. Within each column, we're going to list out all the arrangements. So what would the next column be?
1, 3. Wait, no. 1, 3, 4.
Sure, 1, 3, 4. So this is the set of books 1, 3, 4, and within that column, we're gonna list out all the orderings of just those 3 books, 1, 3, 4, and there's gonna be 6 of them. So now we have 4 out of 10 of the columns, what else? 1, 4, 5. Good, 1, 3, 5. 2, 3, 4. Ink. 2, 3, 4 is what you said? Yeah. Okay, and then what else? 2, 3, 5. Yeah. And what was after 2, 3, 4? 2, 3, 5? Okay, what else? 3, 4, 5. 4, 3, 5?
No.
Okay, so that's interesting,
No,
right?
right.
Because 4, 3, 5 is the same 3 books, 3, 4, and 5, so it should be in the same column. This is a good example. So because we've already listed 3, 4, 5, then 4, 3, 5 would just belong in that same column. It wouldn't be a separate column. 2, 2, 4, 5. Okay, anything else?
I think that's last one.
Okay, very good. So that's 10, and it turns out that we're unable to think of any more because that's all there is. There's 10 columns, just like we expect. And so this leads to the introduction of 2 concepts that we'll talk about. So there's 2 important numbers here. There's the 60 total, which represents the number of ways that we can arrange 3 books at a time out of a total of 5 books. That's our 60. So the number 60 here represents the total number of groups of 3 objects taken from 5. So the number of groups of 3 objects, but in this example it's 3 books. So let's just say 3 books from 5 total. Where the order of the groups within each possibility, within each group actually matters. So we say order matters because the same 3 books in a different ordering gets counted as a different possibility. So in that case, we say that order matters. So the 60 here is the number of groups of 3 books from 5 total, where the order within each group matters. So that's what the number 60 here represents. It's a total number of groupings of 3 books at a time from 5, where the ordering within each group matters. So what about the number 10? What does that represent? So you notice that if we collapse the total number of 60 possibilities down to 10, or the 10 columns, that means that we only care about the number of sets of 3 books from 5, where the order doesn't matter. So all these different orderings of the same 3 books gets collapsed into one set. So the number 10 then represents the number of groups of 3 books from 5 total, where the order within each group does not matter. So that's what the 10 represents. So now we have two different numbers. So now the question might be, when would you use the number 60 and when would you use 10? So that depends on the context. So if you care about order, then you would have an answer that involves the 60. If you don't care about order, then it would be 10. So for example, if I asked you how many different orderings of 3 books are possible from 5, then that, just by the question, that implies that you care about the order, because we're asking about the number of orderings. So that would be 60. That would be the total number of orderings of 3 books from 5. But let's say I asked you, you have these 5 books and you want to select 3 books to put in your book bag to carry to a picnic, for example. And so if you carry these 3 books around, do you care about the specific order of the 3 books you carry around, or do you only care about which 3 books you're carrying? So it turns out that if you're carrying these books somewhere to a picnic, for example, all you care about is which 3 books you have. So then if you want to ask how many different sets of 3 books could you carry around, then that means you don't care about order, and you only care about the number of columns here, which ends up being 10. Okay, so if you care about order, that's the 60. If you don't care about the order, that would be the 10. Any questions? Okay, so now the question is, how do you calculate each of these 2 numbers quickly without having to list them all out like that? So the first number, how do you calculate that quickly? If you have 5 books total and you want to select the number of orderings of 3,
5, you're on 3.
Yeah, this would be what we talked about earlier, which is the 60 comes from 5 permute 3.
Question, does the order of the numbers matter in the perspective?
Yeah, in the permutation by definition, the order matters. So the way that we calculate the 60, all right, so that's the 5 times 4 times 3, and by definition that is 5 permute 3. So that's how we calculated the 60. That's what we already talked about. Yeah.
Out of curiosity, I did my calculator. Why does 3 permute 5 equal 0?
We'll talk about that in more. Yeah. And actually, it's good to talk about it now. So, if you enter this in, you want to make sure that this second argument here is greater than the first argument, because the first argument is greater than the second argument. Because this first argument represents the total number of objects, and the second argument represents the number in each group, versus this is the total number that you have to select from. So if you mistakenly enter them in a different order, some calculators will account for that, and they'll know to reverse it so that it's assuming that you made a mistake. But some calculators might not know that, and this happens to be kind of an undefined operation, which by default is just 0. Yeah. But you should make a habit out of entering this first argument as the biggest number, as the bigger number. Okay, so that's how we're getting the 60, is it's the number of groups of 3 objects from 5 where the order matters. Let's talk about how we're getting the 10. So without listing out all 10, we already actually knew that there should be 10 columns. So how do we know that? So without even having listed them all out, we actually already knew that there should be 10 columns total. Yeah.
We divided by the amount we got in the first column. So we divided by 6 and got 10.
Yeah, we knew that there should be 60 total by just doing this calculation, 5 permute 3. And then we knew that within each, this whole table has a certain number of rows for each column. So we happen to know that the number of rows is 6. And how do we get the 6 quickly? So this 6 comes from, it comes from 3 factorial. So this is simply 3 factorial. So the way that we knew that there were 10 columns is we took the total number of 60 that came from 5 permute 3, and we divide it by the number of rows, which is 3 factorial. So this 10 really came from 60 divided by 6. That's how we got the 10. But this 60 itself came from this expression, 5 per me 3. And this 6 came from 3 factorial. So you notice that we have a permutation here divided by a factorial, and the argument to the factorial matches the second argument of the permutation. And this whole built-in operation here, we actually call a new operation, and we call that a combination. So we abbreviate the combination with a C, and that will have two arguments corresponding to these two arguments here, the 5 and the 3. So you can think of it as the first argument to the permutation and the argument to the second argument to the permutation. So this is 5 combination 3 or 5 C3. So this is the total number of ways that you can have 3 objects in a group chosen from 5 objects where the order within each group of 3 does not matter. And this turns out to be the 10. So go ahead and try to punch this in your calculator. Try to find the C button. It's located nearby the P button. And do 5C3 and make sure that you're getting 10. Any questions? Okay, so now that we talked about what it means to be a permutation versus a combination, let's go ahead and do some quick examples in the time we have left to try to decide when to use one over the other. And by the way, this C stands for combination. That's the noun form. But there's also a verb form for the C, and it's actually choose. So this is kind of weird, because you might expect the verb form for combination to be combine, but this is used so frequently in real life where if you have a certain number of objects and you want to choose a group, usually when people choose a group from a bigger number, they don't care about the ordering within that new group, they only care about the items within the group, the identity of the items. So when you're choosing a number of things, the total number of possibilities is usually the C, and people have made it synonymous with the verb choose. So 5C3 is also the same as 5 choose 3, or 5 combination 3. Okay, so any questions so far? Okay, so now that we talked about what it means to be a permutation versus a combination, now let's go through some quick examples and talk about how we know when we should use one over the other.